Find the force and its direction, right? Well, there'd be no force because there's a gap there. And let's imagine that that gap is filled. Okay. Okay, so 12 volts, 6 ohms, right? So our current is 12 divided by 6 is 2 amps, right? Okay, that's easy. And then notice that this part of this is out of this, out of the magnetic field. So there's no force on this part of it, right? Now let's go, of course the current's going to go this way and this way and this way because it goes from positive to negative, right? The conventional physics current. Electrons go the other way, but never you mind. Okay, the current, the conventional physics current goes clockwise. Okay, now let's do the force on this stretch of wire, right? We don't even know the length of this stretch of wire, so this can't matter if the problem's solvable, right? So let's look at this, right? Index finger up the page, middle finger into the page. My thumb points to the left. So there's that force, right? But if we do the same thing here, obviously we've reversed the currents, so the force will be to the right. And these forces are equal and opposite, and they cancel out, right? Okay, so we don't have to worry about the sides of these things, right? It's this part, though, that will have an unbalanced force, because that'll be a force that's up the page, right? So index finger to the right, middle finger into that page, my thumb is pointing up the page, right? So up the page is the direction of the force. Okay, so again, that devilry was index finger, right? Middle finger was into the page, right? And my thumb was up the page, okay? That force will be because this part is not in the field. What if this was in the field, though? Well, then there'd be no net force, right? There'd be a force this way, this way, this way, this way, right? It's kind of fun, huh? Okay, but this part's out of the thing. It's going to suck it in, right? And then once it gets in there, I guess it'll move at a constant speed or something. That's a good question. Okay, and then let's see. We figured out the force. Now we just need to find the force. So force is ILB. And then the angle is 90 degrees, so we don't have to worry about the angle, right? So what is it, 2 amps times, and then the 0.2 meters, right, times 0.15 newtons per amp meter, or Teslas, right? That's a Tesla. Okay, so 2 times 0.2 divided times 0.15. I'm really spacey here. Okay, 0.06, and that'll be up the page.